Hello everyone. Today I would like to talk about software design and development with microservices and domain-driven design. For the first things that I would like to say is the benefits of microservices. There are 5 types of the benefits. The first one is evolutionary design. That's no need to rewrite your whole application for add new features as microservices and plug them into your existing application. The next is small codebase. For each microservice deals with one concern only, and this results in a small codebase, which means easier maintainability. The third is auto-scale. For freedom to scale only the loaded servants, as that servants will handle the bigger load. The fourth is easy to deploy. Deploy only the needed codebase instead of redeploy the entire application. And the last one is system resilience. For if some of the servers go down, only some features will be affected, not the entire application. Challenging issues to design and develop microservices. The first is inter-service communication, that microservices will rely on each other and they will have to communicate. The next is health monitoring. There are more servants to monitor which may be developed using different programming language. The third is distributed blocking. For different servants will have its own locking mechanism. Transaction spanning. The microservices may result in spanning of transactions over multiple servers and databases. For finding root cause, distributed logic with distributed data increases the effort of finding the root cause. The performance-related root cause can still be managed using APM tools like Neuralink and Dynatrans. And the last one is cyclic dependencies between servants. For reproducing a problem will prove to be very difficult when it's gone to one version and come back with a newer one. For the microservice architecture, these microservice architecture are a specific method of designing software system to structure a single application as a collection of loosely coupled servants. Applications tend to begin as a monolithic architecture and over time grow into a set of interconnected microservices. The main idea behind microservices is that some types of applications are easier to build and maintain when they are broken down into many small pieces that work together. The concept of micro stems from the existing monolithic infrastructure most companies came up using, and especially if the company has been around for a decade or longer, instead of a monolithic architecture. Each component of a microservice architecture has the first is its own CPU, the next is its own runtime environment, and the last one is often a dedicated team working on it, for ensuring each servant is distinct from one another. This architecture means each servant can run its own unique process and communicate autonomously without having to rely on the other microservices or the application as a whole. How API Gateway can act as the facade. I would like to talk about API first. An API gateway is a servant that is a single entry point for API requests into an application from outside the firewall. It's similar to the facade pattern from object-oriented design, like a facade and API gateway encapsulates the application's internal architecture and provides an API to its client. And it is the goal of an API facade pattern is to articulate internal systems and make them useful for the app developer. Domain model Domain modeling is a way to describe and model real-world entities and the relationships between them, which collectively describe the problem domain space, derived from an understanding of system-level requirements. Identifying domains, entities, and their relationships provides an effective basis for understanding, and it can help practitioners design systems for maintainability, testability, and incremental development. This is ACID transactions. What is ACID transactions? ACID is from atomicity, consistency, isolation, and durability. Is an acronym and a mnemonic device for learning and remembering the four primary attributes entered to a transaction by transaction manager. This is four things that from SACID. Atomicity. In a transaction involving two or more discrete pieces of information, either all of the pieces are committed or none are. The next is consistency. A transaction either creates a new and valid state of data, or, or if any failure occurs, returns all data to its state before the transaction was started. The third is isolation. A transaction in process and not yet committed must remain isolated from any other transaction. And the last one is durability. Committed data is saved by the system such that even in the event of a failure and the system restart, the data is available in its correct state. The next is two-phase commit. What is a two-phase commit? A two-phase commit is a standardized protocol that ensures that a database commit is implemented in the situation where commit operation must be broken into two separate parts. And what is two separate parts? The first one is each server that needs to commit data writes its data records to the log. If a service is unsuccessful, it responds with a failure message. But if successful, the server replies with an OK message. And the phase 2 is begins after all participants respond OK. Then the coordinator sends a signal to each server with commit instructions. And after that, View writes the commit as part of its log record for reference and sends back to the coordinator a message that its commit has been successfully implemented. But if a server fails, the coordinator sends instructions to all servers to roll back the transaction. After the servers roll back, each sends feedback that this has been completed. What is CIP theorem? CIP theorem is the concept that a distributed database system can only have two of the three: consistency, availability, and partition tolerance. CAP theorem is very important in the big data world, especially when we need to make trade-offs between the three bets on our unique use case. On this blog, I will try to explain each of these concepts and the reasons for the trade-off. I will avoid using specific examples as DMS are rapidly evolving. The next is domain-driven design. The concept that the structure and language of software code should match the business domain. Placing the project's primary focus on the core domain and domain logic. Basing complex designs on a model of the domain. Initiating a creative collaboration between technical and domain experts. For technical design, what is entities? Objects that have a unique identity and possess a trait of continuity are called entities. They are not defined solely by their attributes but more by who they are. The next is value objects. Objects that describe characteristics and that do not possess any unique identity are called value objects. They care only about what they are, not who they are. Value object creation should always depend on the validity of the data used to create them and how it respects business invariance. Therefore, if the data is invalid, the object instance will not be created. And the last one is aggregates. To mitigate the aforementioned challenge, an aggregation of entities and value objects is needed, restricting the violation of business invariance. And the aggregates are collections of related entities and value objects clustered together representing a transactional boundary. Each aggregate has entity that face outwards and controls all access to the objects inside the boundary. This entity is called the aggregate root, and it's the only object that other objects can interact with. How to maintain consistency with aggregates. For explicitly model an object as being the main entry point to some subset of our model and as being in charge of enforcing the invariance and business rules that apply across all of those objects. Choosing the right aggregate is key and a decision you may revisit over time. The next one is event-driven architecture. An event-driven architecture is a software architecture pattern like this built upon the production, detection, consumption, and reaction to events. An event-driven architecture is including of event series that create event and event customers that use up and react to events. An event is anything that occurs at a well-defined time and is possible to record. An event-driven architecture is able to use an event stream model or pub submodel. The event stream model that event must be written to a log. Events are strictly ordered and durable. Clients do not subscribe to the stream instead. Client is able to read from any part of the stream. The client is responsible of advancing its position in the stream. That means the client can join at any time and possible to reply to replay events. The next is pubs and sub model. The messaging infrastructure keeps track of subscriptions. When an event is published, that event sends the event to it and every subscriber. And after that is received it is possible to repay and new subscribers don't see the event. And next is simple event processing. An event immediately triggers an action in the consumer. As an example, you could use Azure functions with a service bus trigger so that the function executes whenever a message is published to your service bus topic. The next is complex event processing. A consumer processes a series of events looking for patterns in the event data using a technology such as Azure Stream Analytics or Apache Storm. Eventual consistency. In eventual consistency, copies of data don't always have to be identical as long as they are designed to eventually become consistent once all current operations have been processed. Rollback issue. In database technologies, a rollback is an operation which returns the database to some previous state. And rollbacks are important for database integrity because they mean that the database can be restored to be clean copy even after erroneous operations are performed. Sorry, I will talk more about rollback issue. They also are crucial for recovering from database server crashes. By rolling back any transaction which was active at the time of the crash, the database is restored to a consistent state. Dual write problem. A dual write describes the situation when you change data into two systems without an additional layer that ensures the data consistency over both servers. That's typically the case if you use a local transaction with each of the external systems. And this is a figure of it. Here you can see a diagram of an example in which and as long as both operations are successful, everything is okay. Even if the first transaction fails, it's still fine. But if you successfully committed the first transaction and the second one fails, you are having an issue. Your system is now in an inconsistent state and there is no easy way to fix it. Event sourcing. Event source is a great way to automatically update state and publish events. The traditional way to persist an entity is to save its current state. Event sourcing uses a radically different event-centric approach to persistence. A business object is persisted by storing a sequence of state-changing events. Whenever an object state changes, a new event is appended to the sequence of events. Since that is one operation, it is inherently automatic. An entity's current state is reconstructed by replaying its event. Advantage and the drawbacks of event sourcing. For the advantage, it solves one of the key problems in implementing an event-driven architecture and makes it possible to reliably publish events whenever state change. And because it persists event rather than domain objects, it mostly avoids the object relational impedance mismatch problem. It provides 100% reliable audit log of the change made to a business entity, and it makes it possible to implement temporal queries. And the last one is event sourcing, where business logic consists of loosely coupled business entities that exchange events. This makes it a lot easier to migrate from a monolithic application to a microservice architecture. This is drawbacks of event sourcing. It is a difficult and unfamiliar style of programming, and so that is a learning curve. And the next is the event store is difficult to query, since it queries topical queries. Since it requires topical queries to reconstruct the state of the business entities. That is likely to be complex and inefficient. As a result, the application must use command query responsibly segregation to implement the queries. And the last topic that I would like to talk is CQRS. The CQRS stands for Command Query Responsibly Segregation. It's a pattern that I first heard described by Greg Young, and its heart is the notion that you can use a different model to update information than the model you use to read information. For some situations, this separate can be a variable, but beware that the most system secures at risky complexity. And it is my reference of this slide today. Thank you for everyone watching my video. Goodbye.